Okay, we're in section 10.3 of the notes. This is for the homework. What does homework mean? Is something you do at home. Certainly, this is me going over your homework, of course. I think it's in your interest to watch this as well, but I think you probably should be doing the homework before you're watching the video. All right. So this section is about the IVT. And if you go back over the notes here, we would recommend that you would read this and make some attempt to understand what's being presented to you. All right. So, read the intermediate value theorem. It's abbreviated IVT. This was also covered in Math 119. All right. Now, when I go to the homework, I'm going to keep this in mind. It says, suppose F is a continuous on a closed interval AB with W any number between F of A and F of B, where FA does not equal F of B. And certainly we covered this before. We drew a picture for you. We try to make sure it's understandable. I think you probably know by now I like to use W to be 0 for the problems. It doesn't have to be, though. It could be any number. All right. Why do I like to use W 0? It's a root, and I like to look at functions as having roots. All right. So anyway, it goes on to say then if you can, if FA and FB, there's a number between that W, between those two numbers over there, they say you'll be able to find some number C along the x-axis, by the way, that's on the open interval between A and B, such that F of C, when I say x-axis, I really should be saying the abscissa, where FC would equal W. All right. So we go through examples, of course, and the examples are supposed to illustrate the points that are being made in this IVT. All right. Then what do? We did all the examples in class, and then you have homework. It's a chance for you to try. All right. Now, when I'm doing these problems over here, I'm going to actually, I'm not going to go to the whiteboard first. I'm just going to go to a computer first. And what I'd like to do is just this first example, I'd like to visualize it. All right. So what do I visualize? It says use the IVT. Does the function. Let me point out the function we're talking about is going to be y equals x squared over x7 plus 4. It says over here, does it take on a value 1.72? I've got that graphed as well. All right. On the closed interval between 0 and 1. So I got a picture, and I'm going to just zoom out. All right. And I want to point out just one thing at a time. That's the graph. Hope you see what I just did over there. I selected this graph over here. The graph of x squared divided by x7 plus 4. And I see the graph. I clearly see it. I see where the asymptote is. I see that there's a line drawn, the horizontal line over here. No, it's not an asymptote. What's that line? Y equals 0.172. By the way, what am I interested in? I'm interested in this interval right over here. Right, 0 to 1. That's a closed interval. And I see the curve. And I see the line, y equals 0.172. Now, certainly I'm visualizing it. I'm seeing the curve between 0 and 1 looks like this here, right? And I'm seeing this line over here. And the question is there a value C on the open interval between 0 and 1? Of course there is. Look at it right here. All right. Now, when I go to the whiteboard, try to keep this in your memory that I got a continuous function on a closed interval between 0 and 1. There are questions to take on the value. What do I got to do? I got to find a value above that number and a value below that number. And we'll go through that. Of course, it's written down in the blue area, but we'll just walk you through that as well. All right. Let's go to the next question. Next question is, does the function have the value? Well, let's look at that. All right. So I'll just get rid of this. And what I'm going to do is I'll do the next problem. All right. So what's the next problem? F of x equals x squared times 10x. It says, oh boy, what does it say? Well, let's graph it out. All right. Now, sometimes I don't even see it, nor do I. So I'm going to zoom out. Give me a second here. Not sure what happened there. Oh, I know what happened. I wasn't clicking. No, there's something wrong with my graph right now. Let's go back over this. I got troubles. Give me 1 second. Let me see. Oh, you know what? I was zoomed so far in. And that happens sometimes. I guess I was clicking the wrong button and I didn't realize it. Let me get rid of this stuff over here. Get rid of all this nonsense here. It's going to happen when you're using software. So I want to point out, I'm going to graph, y equals x squared tan x. And I'm just going to zoom out a little bit more. And I'm starting to see the asymptotes to it. All right. So someone goes, let me go back and say that they want me to stick between 0 and pi over 8. So I'm going to just, move this thing around a little bit. All right. And then someone says, I wonder where pi over 8 is. And I'm going to graph that and I'm going to get rid of this. I go pi over 8. All right. So I'm going to zoom into this area over here now. All right. So I want to tell you what we're looking at. We're looking at, the function y equals x squared times tan x, and we're looking at, x equals pi over 8. So again, I want to go back and just read it to you. It says over here, I'm between 0 and pi over 8 in a closed interval. So I'm between 0 and pi over 8 on a closed interval. Then the question is, would this function take on the value 0.032? Well, I want to graph that in. And what do I notice? Immediately I notice, and again, I'll zoom in more. Again, this over here, this curve over here is the graph of x squared tan x. This is the interval from 0 to pi over 8. And this is the line y equals 0.32. What do I know? Of course it has a solution on an interval. So there is some value c, I don't know what it is, by the way, that's between 0 and pi over 8 that would produce a success story over here. All right, let's go to the next one. I'm going to zoom out, just equalize axis, recenter, and zoom out again. All right. Again, I'm using technology. Let me look at number 3. And what I want to do is, it says over here for number 3, does this have a solution? Well, what I did over there was I didn't graph out 2 functions. I graphed out 1. I'm basically looking for a root of that problem now. All right. I'm looking for a root and looking at it, I would say, yeah, it has a root. It's right over here. Now let me zoom out. And I think you got an idea what this function looks like. All right. I'm going to zoom back in to the region there. I see the root. And someone says, where did the root occur? I would say, if I were looking at that, I would say, gee, it occurs between 0 and 2, right? I could take that closed interval between 0 and 2. Let me just move that over for you. Now I realize what someone's going to say. I wonder if this it does. It keeps moving over and over and over as we go. It just rapidly goes down. Now you might also say, well, I know there's a closed interval like between 1 and 1.5 where that solution would be. All right. I know there's a value here that produces the root, and that's what's important. All right, let's keep going. Let's do the next one. And that's going to be cosine x equals 4r cosine. And what I did was I'm looking for a root now. All right, I'm looking for a root. And let me just zoom out. And technology is nice. It really is nice. Let me keep zooming out over here. And I'm going to zoom in now. I'm going to go around a region I think is nice. All right. Now, if someone says, yeah, I don't, I'm looking at, you basically should. It's really 119, I'm sorry, not 119, 120 material. You should know the graph of our cosine and certainly know that we're subtracting the cosine curve away from it. The domain of this though is restricted though. Now I'm looking over here, and I just want to zoom into this region over here to show you there's a root there. I definitely see the root. All right, it's right over here. It's really close to 1. So if someone said, what closed interval would you choose? I would choose, let me just pull this back for you. I like integers, by the way. I would choose between 0 and 1. I know it's really close to 1 though. I see that. I clearly see that. All right, let's go to the last question. And I got to do that for you. And maybe not the last one, I guess number 5, right? Yeah, number 5. Let's see if we can do that. And that looks like, x7, 6x minus 10. Yeah, okay. So let me just zoom out on this one over here. And I'm seeing it. All right. Now you can zoom out as much as you want. And let's go back to the question where they want to know, find an interval of length 0.1 and an interval between 1 and 2. And I'm gonna just zoom in on that now. I'm gonna zoom in on that. And I'm gonna use my my mouse to do it. And again, I'm looking between 1 and 2, right? Okay. So I'm looking at this point over here. This is the root of the problem, right? I got to find an interval between 1 and, I'm sorry, an interval length 1 between 1 and 2. Well, I'll be honest with you, I'm just going to look at it and I'm going to put a line in there. All right. So I'm going to put a line in there that sandwiches thing over here. So I'm going to say X equals 1.1. Now, I hope you realize that that is to the left. All right. Now, I want to even get closer to it. So let me try, 1.17, see where that goes. Well, that's getting too close. I'm going to back off, go 1.16. I hope you can agree that that is to the left of the root, right? I'm looking at this visually. All right. Now, they said length of 0.1, right? So I want to put another line in. And I want to go 0.1 above that. And what would 0.1 above that be? It would be, let's see, that would be 1.2. No, I made a mistake there. Sorry about that. I'm screwing up today. All right. I definitely have an interval of length. If I did 1.26 minus 1.16, I would have 0.1, right? I'll let the 0.1. So that's one. Now you might say, could I pick a different one? Of course you could. You could pick as many as you like. All right. Now someone's going to say, hey, that's the one you just picked. But I'll be honest with you, you could pick other ones. Like, for example, I could pick, let me just change this to 1.15. All right. Then what would the other one be? That would be this. I just did it again. I really apologize. I'm really screwing up here. All right. And you might say, well, could I give another interval? You could. And let me I keep it easy for you at least. Let's say I put 1.4 there. Let's go 1.3. Let's go 1.2. What would this have to be? That would have to be that. And certainly that a little more symmetric to me. But someone's going to say, how many intervals are there of length 0.1 that would contain that? An infinite number. An infinite number. Right? An infinite number. All right. So let's go to the next one. Let me just get rid of these here. And that's going to be number 6. So let me just grab out number 6. I realize what students say, I don't see it. Well, I got to zoom out. And I see it now. It's cubic. We expected a cubic to look like that. And what do they say? They say a root between, let's see, in the figure show that this thing has a root between, well, I'm going to put the numbers in now. So 2.75. Put that down. And the other number is 3, right? And I'm going to zoom into that area now. All right. Again, someone's going to say, I don't have this application. You're free to use what you like. All right. You're free to use what you like. And I'm going to say that I definitely see the root over here. what I'm going to do now is I'm going to go to the whiteboard, and we're done using this technology business over here. I do want to point out when I go to the whiteboard, let me just make sure I read that to you correctly. It says the figure has a root on this thing, which intervals 0.25 has a root. Oh, I'm sorry. They want an interval length 0.25. Let me do that for you. So let's take this 2.75 and move it over a little bit. Let's go 2.8. Let's go 2.9. Whoops, too far. Let's go 2.85. Whoops. You know what? I'm going to go below that one now. And what would that be? Let me go 2.8. All right, 2.8. I don't know, 4. I'm sorry. All right. Now, someone says, what's the length of that interval? Well, that would be 0.01, right? What did they want the length to be? To 0.025. So let me see if I can do a little better now. All right. So I want 0.025. So let's do this. And let's go, I don't know, 0.025 below that. Let me do this for you. I'm going to type this in for you. So 2.85 minus 0.025. All right, you see that? And now I got an interval of length 0.25 doing that. All right. And again, you could play around with this. What's nice about using technology is you're not exhausted using, paper and pencil. Learn to use a tool. All right. We're going to go to the whiteboard now. And I got to set my whiteboard up. Just give me 1 second to do so. I forgot all about that, but I got to get my whiteboard out. And I got to do this. I'm going to give you time to think anyway. Let's take a look. And let's see, what page is on? 164, right? So let me I have to import my notes now to my whiteboard. And I'll certainly talk through the blue areas now. And I have to, there's so many pages, I have to scroll through them all. And let me see if I can do that. And I'm going to do it now. Okay. I'm going to do a new share with you. Give me a second. I got to do that again. Okay. I'm going to pull off first question. Now, remember, if you're doing a paper and pencil exam, you don't have access to a computer to do the problem. So the one thing I would do is I would just simply write a couple of facts down. We're using the IVT. They tell me to use the IVT. That's clearly stated, by the way. So we're using the IVT. Now, what am I going to do? Well, I'd probably write down f of x. And you might say, oh, you're wasting time by doing that. In a sense, I am. But I say, when you start getting your hands moving, your brain's going to move along with it. So what do I want to do? One thing I want to do is I want to state f of x is continuous on the closed interval between 0 and 1. Now, why do I know that? The domain of this thing up here is going to be all the real numbers except x can't be minus, what would that be? I guess the 7th root of 4. And by the way, that's a negative number. It's nowhere near 0 to 1. All right. This is good news. All right, I did that. And the IVT really depends on that. And then what I do is, I have to start thinking about, it says using the IBT, is there a value? Let's write this down. So I'm wonder about this over here. So I'm going to say 0.172. I'm going to try to find something above it and something below it. And certainly I'm going to play it safe. I'm going to say, I wonder what f of 0 is. Well, f of 0 is equal to 0. And that's definitely below that number. Now, I get to f of 1 now, right? What's f of 1? Well, f of 1 is going to be 1/5. Isn't that right? Which is 0.2. All right, so I think we're done. All right, let's read this. And I'm reading this over here. They go on to say f of 0, 0, that's below 0.172. They're saying f of 1 is 1/5, it's above it. I got that all written down for you. You know what, again, when I put greater than equal, maybe I should get rid of the greater symbols. I'm on a default mode here. I want to find something strictly above it. Okay, so let me keep going. F is continuous, I did state that. I did state that about the domain of it, by the way. And yeah, so I did it. So I know there's a C. Let me write that down for you. So I know there's a C on the open interval between 0 and 1, such that f of C would equal 0.172. They're not asking me to solve it though, all right? They're not asking that. All right, let's go to number 2. That one's done. It wasn't so bad. And let's pull number 2 on the side. Again, some of these problems might require a calculator. All right. So what do we got over here? Well, I'm looking at the function, and again, the people say, "Oh, you're wasting time writing that down." Not really. I need to write down to start thinking. Well, I know the tangent function is, continuous on the interval between minus pi over 2 and pi over 2. Let me write that down for you. This is continuous on the interval. I'm just looking around for where I get 0 to pi over 8, by the way. So it's continuous on the interval between minus pi over 2 and pi over 2. And I'm looking at the other guy. So I know that f of x is continuous on the interval, closed interval, by the way, between 0. It's contained in the upper interval, by the way, up to pi over 8. I know that much. All right, so now I got troubles now. My troubles are going to be, they want to know, can I get this, the 0.32 somewhere in the middle of that? And I might have to use a computer to help you with that. So I'm going to write this over here. So I'm using the IBT. Let me make sure you know what I mean by that. I'm using the IBT. My guy's continuous. And what I'm going to do is just make a stab at it. So I'm going to say, what am I going to say? 0.032. And I'm going to say, is f evaluated at 0? Well, that was easy. That was 0, right? But now I got to start to worry about that pi over 8. All right. And that's tough. All right. So I'm going to say, I'm going to make a stab at it. And what I'm going to do, I'm going to say f of pi over 8. All right. But here's my problem. I don't want to go through a lot of work, although you could. Like, for example, if you looked at pi over 8, and what would that be? Well, that's the same thing as pi over 4. It's a half of it. So I could use the half angle identities to figure it out. You could. And where'd you learn about the half angle identities? In math 120. But you know what? I think it'll be a lot of work. And I think of myself as, you get tired sometimes. Maybe you just want to simply say, you know what? Let me see what my calculator says. So if you took your calculator, what would you get? You would get approximately 0.0639, yada, yada, yada. Is that number greater than 0.32? Yes. So what do I know now? I know that there's a C contained on the open interval such that f of C would equal 0.032. Do I know what the value C is? No. But are they asking me for that? No. Let's look at our answer key. Well, pretty much what we wrote down over here, the approximation, f of x continuous, all points on that closed interval. And certainly there's going to be something between 0 and pi over 8, which means the open interval. Okay, let's go to the next question, which would be number 3. All right, let's look at number 3. Now, this is a problem that's, again, there's a variety of ways of doing it. I tend to go for rewriting these things so they're functions. All right, now someone says, why do you do that? Well, because it makes it more familiar with the intermediate value theorem. So let me go through that step for you. So 2 to the x, whoops, let's go back to black ink. 2 to the x plus 7 to the x equals 8 to the x. Well, I would solve for 0. And then the big question, you wonder, does this thing have a solution equal 0? So I'm going to say f of x equals 2 to the x plus 7 to the x minus 8 to the x. And my w is 0. So what I'm looking for is I'm looking for an interval that would contain 0. Now, what do I mean by that? There's something above it, something below it. So let me write this down. Again, I'm stabbing in the dark. What's f of 0? Oh, before I do this, this thing is continuous on the whole interval. Now, yeah, I don't want to, I got to find some closed interval though. I can't say just the whole interval. What's f of 0? 1 plus 1 minus 1, which equals 1, which is definitely greater than 0. All right. Now let me do another one. Let me do f of 1. That would be 2 plus 7 minus 8, which would equal 1. Well, that's greater than 0. All right. 2 plus 7 is 9, 9 minus 8. So I got to keep going. I got to find something that's going to be negative now. Let's keep going forward. My suspicion is that 8 is going to take over at some point and make it negative. Let's do 2. So what'd you get over there? 4. Remember, I'm picking numbers that I can compute with. Plus 7 squared, that's 49, right? Minus 8 squared is 64. Now, what would that give you? Well, 4 and 49 is 53. Minus 11, right? Definitely less than 0. So I'm going to say, if it's continuous between minus infinity to infinity, what I'm going to say is this: f of x, which is 2x plus 7x minus 8x, is continuous on the interval between 1 and 2. Okay, what's my w? 0. I'm looking for the root. So 0. So I want to find something below and something above. Have I found something above? I did. I found 2 things. You can use either one. I'm going to use f of 1 though. What's f of 1? That turned out to be 1. That is definitely above the 0. Did I find something negative? I did. And what did I find? F of 2. What's f of 2? Turned out to be minus 11. So what do I know? Let me get a little, I'm going to put a little line because I know it looks like it's moving and someone says, I wonder what's there. I'll just make sure you're not looking at that and seeing it's the same thing. So what do I know? I'm using the IVT. Let me outline it for you. It even says it. Okay. What am I going to say? There's a C on the open interval between, well, between what? 1 and 2, such that f of C would be equal to 0. All right, this one's done. Let's go back over the key. What I do, I wrote it as a function. Again, it really corresponds to that intermediate value theorem. I got to write functions down. F is continuous. They chose between 0 and 2. I chose between 1 and 2. It doesn't matter. There's an infinite number of intervals you could choose. F of 0 was 1. I got that written down. And f of 2 was minus 11. I also have that written down for you. All right. By the IVT, there's a C on the open interval. Again, I chose between 1 and 2, such that FC is going to equal to 0. All right. They're not asking for a solution, though. They're saying, is there a solution? And the answer is yes. Let's go to number 4. And again, I'm looking at these things over here, one at a time. And let's look. Okay. Blow it up. And I think you know what I'm going to do. I got to get a function down. And what does it say? Cosine. Whoops, let's go back to black ink. Cosine of x equals 4 arc cosine of x. Well, I'm going to get a 0 because I really do like the 0, by the way. So I can say cosine of x minus 4 arc cosine. I'll write this way, by the way, equals 0. And I'm going to call this my function. I want to say my function. This is my function now. Maybe I should write that down for you. So I got to tell you where this thing is continuous, right? So this thing's continuous. And I want to remind you, when you took Math 120, your teacher said, memorization, at least I hope they told you, memorization is not the way to go. But, the invertible region of cosine curve, you did something like this, and that occurred between 0 and pi, right? And then, the range of that is between -1 and 1. Okay, so I'm going to say this is continuous on the closed interval between -1 and 1. All right, let's keep going. And what am I looking for? I'm looking for a 0. All right, so I got to start stabbing at it. And someone says, why do you need to stab at it? I got to know what I'm going to get. And I'm going to look at the, I don't know, let's look at the 1 first, all right? Let's look at f of 1. And what would f of 1 give you? I don't think I need a calculator. I'm going to still write it down. Cosine of 1 minus 4 arc cosine of 1. All right, so I'll write this down. F of 1 is cosine of 1. Now I'm wondering what the arc cosine of 1 is. Well, if you took Math 120 and you studied that material well enough that you got a passing grade in it, you should realize that's 0. All right, I'll write that down for you. -4 times 0 is just 0. And you should realize the cosine of 1, and 1, if I look at it, this would be pi over 2. The cosine of 1 is definitely a positive number. So I'm going to write that down for you. Cosine of 1 is definitely greater than 0. I know that much just from my studies from Math 120. Now, I'm looking at that -1. I'm thinking to myself is, I don't know if I want to go there, but I guess I could. I'm going to try to get a smaller interval, and I'm going to try saying that it's also continuous on 0 to 1. I'm going to try this now. I don't know what's going to happen. Let's see what happens. So what's f of 0? Well, the cosine of 0, maybe I should write this down. Cosine of 0 minus 4 arc cosine of 0. What's cosine of 0? It's 1, isn't it? Minus 4. What's the arc cosine of 0? Pi over 2, right? I don't know. Let's see what happens. You get 1 minus 2 pi. Well, I hope you know that 1 minus 2 pi, whether you have a calculator or not, is definitely a negative number, right? So I'm going to say that f of 0 is definitely negative, so it's below 0. So I'm going to cross this out. I'm going to stick with the 0 and 1. All right. So what did I do? I wrote a function down. I'm looking for when it takes on a 0. And I found it. What did I find? I found this. I found there's going to be a C on the open interval between 0 and 1 such that f of C would equal 0. And what are we using? The IVT. All right. And we just showed it has a solution between 0 and 1. Okay. Let's take a look at the next question, number 5. I'm going to shrink this down a little bit. Oh, but let me look at the key first. So what do we do over there? We wrote the function down. We said it's continuous 0, 1. We did do that. I did f of 0. I said 1 minus 2 pi. We did that. I did f of 1. Although I didn't use a computer to do that, I did say it was a positive number. It goes on to say IBT. We're using that. There's a number c between 0 and 1, such that f of c would be equal to 0. All right. This is good news. All right, let's keep going. And I guess I'll have to do number 5 now. All right. So number 5, I'll put on the side for you. Oh, I messed up again. I did it again. And push this over a little bit. Push this down. So I'll push this stuff up. Push this over. Make this bigger. Okay, we're doing 5 now. So I think you know what I want to do. I want to write a function down, and I'll put this over here, f of x. Whoops, got black again. F of x equals x7 plus 6x minus 10. And then I got to say, I got to look at this thing, and this is continuous everywhere, right? Continuous minus infinity to infinity. What do they say? They want me to find an interval between 1 and 2 that is length 0.1. All right, so if it's continuous between minus infinity and infinity, what I would say is f of x equals x7 plus 6x minus 10 is continuous on the closed interval between 1 and 2. All right, so what do they want me to do? They want me to find that as a root. In other words, there's a 0 on that interval. So what you have to do, and I want to point this out to you, I don't want to waste time with a calculator, and I'll tell you why. The 7th power is really tough to compute by hand. So I'm going to recommend that you use a calculator. And what you're going to do on a calculator, I'm going to put this down for you. On a calculator, you're going to rapidly go through the numbers. So for example, on a calculator, you might want to do f of, some number on the interval. And again, you can start at 1 if you want, but I'm going to point out, you should probably graph this thing out, and you realize it's somewhere around, 1.16 or so. Right? And you're going to find out f of 1.26. All right. Now, someone says, if I don't have a calculator, how would you do that? It would be just a lot of arithmetic, I'll be honest with you. Arithmetic I would prefer not to go through. All right. But anyway, kind of looking at it, I'm going to say, you got the idea, right? That, one of these things is positive, one of them is negative. All right, let's write this down. So, maybe I should get my calculator out. I'm going to go to Sage on my calculator. I'm going to do these computations for you in my Sage calculator. Just give me a moment. I can open up my computer. You don't see this though. And the reason you're not seeing it is because my whiteboard open. And I'm actually going to use my computer now to, open Sage for one, and then do a computation. And I'm actually going to do it. All right. So I'm going to say f of x. Again, I'm using Sage. It's my calculator of choice, by the way. X7. Let's see, plus 6x, 6 star x though in Sage, right? Minus 10. And then I'll do f of 1.16. And I get this number. I'll write it down for you. Minus 0.214. Negative number, right? And I'm going to do this one now. And again, my calculator is really easy if I'm using Sage. I actually find it easier to use Sage than I do a handout calculator. It's a lot more powerful too. And this one turns out to be positive 0.214. I'm sorry, I made a mistake there. 2.6, I'm sorry. 0.2. So what do I know? I know f of 1.26 is above the 0, and I know f of 1.16 is below. So what do I now know? I know I have an interval. I'm going to refine this, by the way. And let me just go over here and do that for you. I'm going to cross this out. My interval now is this: 1.16, comma, 1.26. What's the length of that interval? It's 0.1, right? It's 0.1 units long. And that's what they want me to do, right? So I found an interval. What do I now know? I know there's a C on the open interval between 1.16 and 1.26, such that f of C is equal to 0. I found a root. Okay, let's go to number 6. Number 6, I guess they're giving me a calculator. And let me just kind of move things around here. I realize sometimes when I move things around, they get all messed up and stuff. And let me just push that over there. And let me look at number 6 now. So it says, I have a figure, right? 41 on page 164. And they got a graph, and I'm glad for it because I don't have to do the graph myself. I see the graph of f of x. All right, this is f of x, and this is the graph. Again, I'm trusting you. You don't want to trust me. I want to try it yourself. Has a root between 2.75 and 3. Let me put on what I mean by that. 2.75 and 3, over here somewhere about. I definitely see a root. And I'll point out what I mean by that. I'm seeing a root here. So what am I saying over here? I'm saying that x cubed, whoops, I didn't mean to do that. X cubed minus 8x minus 0.25 is equal to 0. And I'm seeing it. I'm seeing the root between 2.75 and 3. All right. They gave me a picture. All right. They gave me a picture. All right. It says, which of the intervals of length 0.25 contains the root? And I got to be honest with you. I got to go to the next page. As I do that, though, it's going to be tough, right? Because you're going to have to use a computer to do it. Right. I'm going to grab this thing over here. And I grabbed the whole, I grabbed too much. I'm sorry. I'm going to grab this thing here. And you know what? It looks odd to me. Let me go backwards. And I'm going to grab it again. All right, I'll put this over here. All right, let me copy it. And let me go to the next page. Paste it in. And I know it's difficult. All right. So I want to go back, and they want an interval of length 0.25. Okay. Okay, this has length 0.25. I'm sorry, 0.25. This looks good. This looks good. Let's say 0.25. This looks good. This looks good. And this looks good. They'll all have the same length. All right. What you got to do, though, and this can get really tough for students that don't know how to use a computer, you're going to have to evaluate the function f at their endpoints. So I'm going to go over here. And I want to point out, if you're using Sage, just define the function. This is the function. And then what you're going to do, let me underline this for you. This is the function you're going to use. You want to look at the endpoints. You want one to be positive, one to be negative. If you do that, you're going to find out that this one's okay. This one is not okay. This one is not okay. This one is not okay. And this one is not okay. But it's going to require, for most people, myself included, the use of a calculator. What calculator? My suggestion you use? Sage. If for whatever reason you're unable to use a calculator to do these exercises, please come see me during office hours, and I'll be more than happy to help you with this. Thank you.